Hello everyone, this is your online assignment tutor. This video again we want to talk about log reading. In this video about log reading, I we also want to look at the laws of log reading. So in mathematics we abbreviate it to be log. So excuse me. Okay, what is log reading? What is log reading? Well, we have a situation here where we have, in the previous video we did indices. We look at what are indices. We're able to look at the definition. So also it's essential for us to also define what logarithm is. So what is logarithm? So the logarithm of a number, to a certain base. So the logarithm of a number to a certain base So the logarithm of a number to a certain base is the power, power to which the base must be raised, must be raised to give that number, to give that number. So let us put it in mathematical form. So the logarithm of a number, so every logarithm has a base. Let's say log n base b. So the logarithm of a number, this is the base, this is the log n. So the logarithm of a number to a certain base b is the power to which the base, let's say we have log n base b equals to x. So it means that the definition of logarithm is saying that for we to find n, then it will be what? B raised to power x equals to what? To n. That is the definition of logarithm. So logarithm is saying that, what is basically saying is this: if we have the log of a number to a certain base, for we to find the number, we have to raise the base to a certain power, which is equals to x, to a certain power that will equate the number. So b raised to power x is equal to n. So in analyzing logarithm, we can turn it to an index equation. So it means that to find n, the base must be raised to a certain power, which is equals to what? X, which is unknown. So that is that for that. So another thing that we have to know is this: we can evaluate log 1000. What is log 1000? Actually, when a log does not have a base, it is naturally in base 10. So if somebody writes log 1000, it's the same thing as log 1000 base 10. The same thing as what? Log 1000 base 10. So if you are being asked to evaluate log 1000, which is the same thing as log 1000 base 10, you are going to equate this to a certain number, which is we don't know. That is how we are going to find it. So to find this log 1000, so you are going to read 10 raised power x equals to what? 1000. 10 raised power x equals to 1000. So we are going to find our x now. Therefore, we are going to have what? 10 raised to power x equals to 1000 is 10 raised power 3. So we have a situation of the same base. So this one cancel. Therefore, x will be equals to 3. So log 1000 is what? 3. Log 1000 is 3. Let's look at another question. Let's say evaluate log 0.125. 0.125 base 2. So let us evaluate that. 0.125 what? Base 2. 0.125 base 2. So how are we going to evaluate this? So you are going to equate it to a certain number. Let's equate it to a certain number. Let's say p. Therefore, it will be 2 raised to power p equals to what? 0.125. 2 raised to power p equals to what? 0.125. So let's solve that. So if we solve this, we are going to change this to a fraction, 0.125. So we have 2 raised to power p equals to, now changing 0.125 to a fraction, you can see that it will give us 125 over, how many times are you going to shift the point to the right? 1, 2, 3. So 3 times 1 over 1000. So what do you have now? You have 25 year 5, 25 year what? 40. So 5 year 1, 5 year 8. So you are having 1 over 8. So you are having what? 1 over 8. So you have 2 raised power p equals to what? 1 over 8 is what? 2 raised power what? 3. So if you look at this very well, you can change this 1 over 2 over 3 to be equal to 2 raised power minus 3. Since 2 and 2 are the same base, you can equate them. Therefore, our answer p is equal to what? Minus 3. So therefore log 0.125 base 2 will give us what? Minus 3. So log 0.125 base 2 will give us what? Minus 3. That's good. So we are seeing in the course of this video, see going to look at some questions, but quickly let's move to the laws of logarithm. Laws of logarithm. So the first one is what we call the multiplication rule. And the multiplication rule say that if you have log adding each other, which are the same base, for example, if you have log p base, let's use base b plus log q base b. So the logarithm, the answer that one we gave us, that is the first law. We have to take note of that. Answer it will give us will be what? Log p times q, because it's addition, it will attract what? Multiplication. Like the one we did in indices, where we have a raised power s times a raised power y, we give us a raised power s plus y. In this case, you have log p base b plus log q base b. He will give us log p times q base b. So this is a very important law in the logarithm. So let's look at number 2. We have log p base b minus log q base b. So it will give us what? Log p divided by q base what? Base b. Base b. Log p divided by q base b. So minus will attract division. This is very important. Minus will attract division. So if you have this log, again, this log p raised to power n base what? Base b. So this one, the law say that the n, which is the power of p, can multiply the log. So now this one can give us n log p base b. This is a very important law in logarithm. Very, very important. Take note of that. So another one we're going to talk about is we have what we call the change of base. For example, let's look at log p base what? Base b. We want to change it to a log in base k. So we want to change this log p base b, log p base b, to a log in base k. So the way we go about it is this. Very, very simple. Very, very simple. It's not difficult. So we are changing to a logarithm in what? In base k. So what you need to do, just write your log over, write another log. Since you are changing to a base k, put your k here, then the p, put it here. That is log p base k. Then your b here, which is base here, put it here. So this is log p over base k, log b base k. So you have changed it to a what? You have changed the base to a logarithm in base k. So this is actually what we're talking about, changing the base of logarithm. So another one I want us to know is actually this. If you have the same base, if log p base b is equals to log q base b, then that implies that p is equal to what? Q. This is actually true because they have the same base. So if log p base b is equal to log q base b, that implies that p is equal to what? Q. So let's look at another beautiful law. If you have this log p base p, I'm just using p. You can use any letter. Log p base p, because they are the log p is having the same base. If the base and the log are identical, is going to give us what? 1. So log p base p will give us what? 1. Will give us what? 1. What are we saying? It means log 10 base 10 is going to give us what? 1. So let's take another one. Let's look at log 1 base a, or better still, let's use our b, log 1 base what? Base b. Anytime you have to see a solution, it's going to give you 0, because b raised by 0 is equal to 1. Anytime you have log 1 base anything, it's going to give us what? 0. So it's what? 0. So another one I want us to actually look at is this log n base b raised to power 1 over a. So log n base b raised to power, the law states that if the base has a power, the inverse of that base, the inverse of that power is going to multiply the log. What is the inverse of 1 over a? That is a. So this one become a log n base what? Base b. Very important. That is a very important law. Logarithm. Very, very important. So another one we have to look at now is actually some questions. We have some questions. A question. Let's look at this question. Evaluate log square root 27 over log 9. We are told to evaluate this. That is what we are told to evaluate. So first of all, this log, they are in base 10, even though you are not given, because I told you that anytime you have log and they don't have base in it, they are naturally in base 10. So you are going to have log square root 27 is going to have 27 raised to power what? Half. Log 20. So this one is what? Log 9 is going to have log 3 raised to power what? 2. You see, is that fine? Go, fantastic. So another thing you have is that we'll have is this. So we are going to, one of the laws say that if the logarithm has but a power, it can multiply the log. So you can have half log 27 is what? 3 raised to power 3. Is that not so? That is 3 times 3, 9. 9 times 3, 27. That is 3 raised to power 3. Then this one can come here because the law that we talked the other time that bound this half coming to multiply log 27. Also, the law is also applicable to here. 2 is coming to multiply the log. Now we have 2 log 3. 2 log 3. So this will give us, this will be equal to, of course, this 3 raised to power 3. The 3 that is the power can multiply half. That will be 3 times 1 over 2 log 3 over log 3. Since you're having log 3, remember our 2 is here. Since you're having log 3, so this one cancel. So you are left with